To check whether the given function y equal to the product of x and e to the power of x is a solution of this given differential equation, we need to satisfy this equation by using this function y is equal to x times e to the power of x and taking its first and second order derivatives, substitute them here, and if we could satisfy the equation, then this is really a solution of the differential equation. So first, as mentioned, let's try to solve first the first and second order derivatives of this function. Take note that this here is actually a product of two different functions. You have x and e to the power of x. So we could use here the product rule when we try to derive or solve its derivative. And we know that the what they call this one, the first order derivative, which also be true for the second order derivative later if there exists the same thing, that we can get its first order derivative by taking the first and taking the first function x, and then taking the first order derivative of e to the power of x, which is still e to the power of x, plus taking the derivative of the first function, that's 1, and copying the second. Again, let me repeat this. The first one is copy the first and taking the first order derivative of this, which is just still e to the power of x, plus taking a derivative of this, the times copying this one here. Of course, you can interchange that because this is still addition, so it's commutative. Therefore, the first order derivative is equal to x e to the power of x plus e to the power of x. Okay, but what is its second order derivative? That's the next thing. The second order derivative will be taking the derivatives of this separately as well. So since this here is similar to that and its first order derivative is this entire, so we can just automatically copy that. Okay, you have x e to the power of x plus e to the power of x. That's just for your first, right? For this first alone, this is just for the derivative of this first. You already given it here. Plus, and the derivative of this second is also e to the power of x. So basically, the second order derivative here is x e to the power of x plus e to the power of x plus e to the power of x. You have x e to the power of x plus twice of e to the power of x. So we'll be using this second order, first order, and even the y itself. And let's see if this could satisfy this equation here. The equation is the second order derivative minus 2 times the first order derivative plus y is equal to 0. Let's check. Okay, substituting that, you will have x e to the power of x plus twice e to the power of x, okay, minus twice the first order derivative x e to the power of x plus e to the power of x plus your y, which is this x e to the power of x equal to 0. Let's check if it's really equal to 0. I think it will be. Let's just do it. X e to the power of x plus twice e to the power of x minus 2x e to the power of x minus 2e to the power of x using distributive property plus x e to the power of x equal to 0. This is 1x here as well. So 1x e to the power of x minus 2 plus 1, that's of course 0. Okay, again, you have 1x to the power of x minus 2x to the power of x is negative 1 plus 1, so that's 0. And this here, 2e to the power of x minus 2 to the power of x, 0 equal to 0. Okay, so with this in mind, with this here, we already shown that this given function is really a solution of this differential equation because it satisfies the equation. The trick here, and probably the trickier part, is in solving for the second and the first order derivatives, because you need to use here the product rule. And by the way, again, I did not use the product rule for the second because I already have this one here. This is just similar to that, so I'm just copying the entire, and that is for the entire solution. Thank you very much for watching.